everyone. Hello, everyone, and welcome to my lab. Are you ready to learn? Yeah! Are you ready to have some fun? Yeah! Well, let's get started then. Here we go. Ready? That got your attention, didn't it, right? That's what I want you to be doing, paying close attention to what's going on so that you can really enjoy and learn. What is this? What does it look like? Looks like a light bulb. Yeah, it's a fluorescent light bulb. So I'm just going to hold it about halfway like so and push the button. Bring this close. Some of you were covering your ears again, but that wasn't necessary. It's all right. It's okay to be cautious. So we do it again. And I lengthen this where I'm holding it. You like that? Yeah. Well, thank you. Actually, I need a couple of more tubes that I seem to be missing here. I wonder, could someone please bring out the tubes? Oh, yes. Thank you, Art.
Sure.
Thank you very much. This is what I'm looking for. So let's try this one here. You're holding it tight. Okay. Let's try the other one. Let's try this in the dark and see what happens. All right? Here we go. How about the other? All right, with the lights back up again. The spark transferred energy into the gas inside the light bulb. And then each of these light bulbs is coated with a different color coating. And so the energy is transferred back from the gas into the coating, and we see different lights. I'd like you to welcome Professor Arthur Benjamin from Harvey Mudd College in California. Welcome, Art.
Oh, thank you. Bassam, I'm here as a mathematics professor because this is your 36th anniversary, and
yes.
Oh, isn't that incredible? 36 years of doing this, wouldn't you say? And now, as a mathematician, I love the number 36 because it's a perfect square. It's 6 times itself, and any number that is, when you multiply a number by itself, that's called a perfect square. Now, I'm going to need some people to help me out here who are pretty comfortable with calculators. Any volunteers in the audience? Okay. How about the two of you? Would you join? What's your name? Brian and Stephanie. Let's give Brian and Stephanie a nice round of applause. Over on this side, please. What I'm going to try and do now is to square in my head 3 two-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll ask is for 3 people in the first row here, 1, 2, 3, to each yell out a 2-digit number, and if you would square the first number, the second, and the third, I will try and race you to the answer, okay? So quickly, a 2-digit number, please. 56 squared, okay. 25 squared, okay, and one more. 23. Would you call out your answers, please? 3,136.
625.
625.
529.
Thank you very much. Let me take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone I point to call out a 3-digit number. Anyone on our panel verify the answer, okay? So a 3-digit number, sir, a 3-digit number, please. 637. 637 squared is 405,769. 405769. Good. Another 3-digit number, please. 313 squared is 97,969. 97969. Yes, good. Another 3-digit number, sir. 862, that's a hard one. Is that 733,044? Yes?
Yes.
One more 3-digit number, sir. 989 is 978,121. Thank you very much.
See that?
Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, you can all take your time on this. I will not beat you to the answer here, but I will try to get the answer right. To make this a little bit more random, let me use 4 people. Let's say these 4, 1, 2, 3, 4. If you'd each call out a single digit between 0 and 9, that will be the 4-digit number that I'll square. So a single digit, please. 8. 7. 3. 4. 8, 7, 3, 4. This will take me a little bit of time, so bear with me. 76,282,756. Wow. Yes.
Yes.
Thank you very much. Now, I would attempt to square a 5-digit number, and I can, but unfortunately your calculators cannot. 8-digit capacity, don't you hate that? So since we've reached the limits of our calculators, I'd like to do the last thing a little bit trickier. Let's take the magic number of the day, 36. Would you each square that on your calculator again? So you'll have 1,296, of course. And now take that number and multiply it by any 3-digit number that you'd like. But don't tell me what you're multiplying by. Just multiply it by any random 3-digit number. So you should have as an answer either a 6-digit or maybe a 7-digit number. How many digits are in your answer there, Brian? 6 or 7? You're still working on it? Okay, so take 1,296 times any 3-digit number. Stephanie, how many digits are in your answer? 6. And Bassam?
6.
6. And Brian? Still working on it. Okay. Is there any possible way that I could know what 6-digit numbers you have? Say no. No. Good. Then I shall attempt the impossible, or at least the improbable. What I'd like each of you to do is to call out for me any 5 of your 6 digits, any 5 of them, in any order you'd like. 1 digit at a time, I shall try and determine the digit you've left out. Now, Brian, do you have a 6-digit number now? Okay, or a 7-digit number? 6. Would you call out any 5 of those 6 digits in any order, please?
4, 3, 7, 1.
I only heard 4 numbers. You said 4, 3, 7, 1.
2.
Did you leave out the number 1? Good, that's 1. You've got a 6-digit number. Call out any 5 of yours in any order, Stephanie. Loud and clear.
3, 6, 1, 5, 8.
I think you left out the number 4?
Yeah.
Good. The odds of me getting all 3 of these right by random guessing would be 1 in 1,000, 10 to the 3rd power, okay? Bassam, any 5 of yours, really scramble them up this time.
8, 2, 4, 7, 6.
Ooh, having a little bit of trouble with this one, Bassam. Do me a favor, concentrate on the digit you left out. Doesn't do a darn bit of good, it just looks dramatic. But you know what? I seem to be getting a lot of nothing here. Bassam, did you leave out a 0?
No.
Because it seemed like you were thinking of nothing. Maybe you always think that way. That's okay. Concentrate harder. I'll get it this time. You left out the number 9.
9 it is.
And let's give all 3 of these people a nice round of applause. Thank you very much. Good job.
Thank you. Now, that's really a fantastic display of a very skilled person, isn't it? Yeah. Huh? Yes?
Would you like to see how some of this works?
Yes, I'd like to.
Okay, well, would you like to see how some of this works? Yeah. Okay, now I'll show you how I square numbers. I'll do some small ones first. I'll start with one that some of you even know the answer to already. If we wanted to do 12 times 12, that answer is 144. Now, here's how you would calculate it using the method that I use. So 12 is not a bad number. What number close to 12 is even easier to use? 10. So I'm going to go down to 10. I'm going to go down 2 to the number 10. Now, whatever comes up must come down. If I go down 2 to 10, I also have to go up the same distance to the number 14. So the first thing I do is 14 times 10, which is 140. Almost done. All we have to add to this is the square of the number we went up and down. We went up and down 2. 2 squared is 4, and there's your answer, 144. Let's try another one. Let's say the problem was 36 squared, okay? So 36 is our magic number of the day. So this time, what's the nearest easy number? 40. Well, 30's close, but 40's closer, so I'll go up 4 to 40, and therefore I'll go down to what number? 32. Now we do 40 times 32. Now don't panic. That's just 4 times 32 with a friendly 0 attached, and I like zeros. 4 times 32. We'll do it from left to right. 4 times 30 is 120, plus 4 times 2 is 8, gives us 128. With a friendly 0, that's 1,280. All we add to that is what? The square of 4, which is 16, and there is your answer, 1,296. Now, it'll take you some practice before you can do it really fast, but I want you to try one on your own, okay? Try to square. When you think you have the answer, raise your hand. Try and square the number 97. Okay? When you think you've got it, raise your hand. Think about what you'll go up to and what you'll go down to. Multiply them together. And think about what you'll add. What did you get? 9,409. Give her a nice round of applause. Terrific job. Now, what I hope you did was you went up 3 to 100, down 3 to 94, multiplied them together to get 9,400, plus the square of 3 is 9, and there is the answer, 9,409. Thank you very much.
Fantastic. Really fantastic. Now, Art, now this is really, really a wonderful skill that you have. Were you born with it, or how did this come about?
No, this was, by all means, this was, as you said, a skill. It's nothing that you're born with. I may have been born with an interest in numbers, and I certainly spent a lot of time playing with them, but my firm belief is to get good at anything, whether it be mathematics or science or sports or music, is 99% a function of practice, putting in the time. Now, it doesn't have to be boring time. As you can see, it can be a lot of fun, and that's the point. Put in the time and have fun with it. Not only is science fun, I hope your audience sees that mathematics can be a lot of fun, too.
It is indeed. Thank you very much.
My pleasure.
Art, thank you so much. Thank you. At this time, I'd like you to welcome someone who has been my collaborator for a very long time, my longtime collaborator and friend, Dr. Rodney Schreiner. Rod? Hello, Rod.
Hello, Bassam.
Happy to see you here.
Glad to be here. And I have a number of experiments to show you. These involve electricity. So the first thing I will do is plug in my equipment so I can get some electricity here. And the first experiment involves this glass tube, which has some stoppers in the end. I'm going to take the stoppers off just to show you that it's an empty glass tube. Well, it's actually not empty, is it? There's something in it. What's in it? Air, exactly. So first, I'm going to clamp the tube into a stand so that I can handle it more easily. And what I'm going to try to do is to send electricity through the air in the tube. So first, I need to have some way of getting the electricity in. So I have a rubber stopper with a nail in it. I'll put that on one end. And I have another rubber stopper with a nail through it in the other end. It's also got a glass tube, which I will tell you about shortly. Now, we know that air does not conduct electricity very well, don't we? If it did, we'd have trouble with our electrical outlets. They'd be spewing electricity all the time, but they don't. 110 volts is not enough to get electricity to flow through air, but we have seen lightning flow through air. That's electricity. It's very high voltage electricity. So what I'm going to try is to use high voltage applied to the two nails to see if I can get electricity to flow through the air. I'll need a transformer. A transformer is a device that transforms one voltage into another. So it's plugged into a 110-volt outlet, and it transforms that into what the label says here, 10,000 volts. So I'm going to put 10,000 volts across these two nails. And I'll turn on the transformer. Lights on. Nothing seems to be happening. The reason that nothing is happening is that the resistance of the air is still too high. But if I take out some of the air, I can lower the resistance and maybe get some electricity to flow through. I'll pump out some of the air. That's what that glass tube is for. I'll attach it to this rubber hose, which is attached to a pump below the bench. And before I turn on the pump, I'll have the lights turned down so that we can more easily see if anything happens. So there's the pump making those funny noises, drawing the air out of the tube. And when the pressure goes down, it begins to glow. Now, that's cool, isn't it? Look at that. There it is, glowing. Now, what we have in here is called a plasma. Plasma is one of the 4 states of matter. We're more commonly familiar with the 3 of them, solids, liquids, and gases. But I'm sure all of you have seen a plasma before. Let's turn the lights on so you can see what I'm doing here. I'm going to turn off the transformer now and detach the pump. You've all seen plasmas. Can you think of where you may have seen one? Let me give you a hint. See my lunch sign? My lunch sign? That lunch sign is made exactly the same way that I got the electricity to flow through air. However, my lunch sign is different color than the glow that we saw from this tube. The lunch sign is red and blue. The blue tube contains mercury gas, and the red tube contains neon gas. And because of the neon gas in that sign, it's often called a neon sign. Now, an odd thing about the way we see color is that we don't see all the possible colors there are in light. For example, when you go out on a bright sunny day, you don't see in the light of the sun all the colors it contains. But if you look at the surface of a compact disk in bright light, such as the light in this room or on a sunny day, what do you see on the surface? You see a rainbow. You see all the colors. That's because the surface of this disk is breaking the white light into all of the colors that are in white light. Well, if we shine the light from one of these gas tubes on this surface, we can see the colors that are produced by that lamp. And that's what I have set up here. I have a piece of compact disc right here and this clamped to this stand. There's a camera here taking a picture at just the right angle so that you'll be able to see it. And I have a transformer here which will produce high voltage for these little tubes that contain various gases at low pressure. The first one is mercury, which is, when I turn it on, you see it produces blue light. But if you look at the reflection off of the compact disc here, you will see that not only does this produce blue light, but it also produces green and yellow. Do you see the green and yellow when you look right at the lamp? No, the blue dominates. So that's all you see, just the blue. But there is also green and yellow produced by this lamp. Let's look at the neon lamp and see what it produces. You already can guess one of the colors it produces, can't you? Right? Very likely it's going to produce red. So there's the neon. And if you look at the colors the neon lamp produces, you'll see there's a lot of stuff on the red, but there's also a color in there that you don't see when you look right at it. Green, exactly. There's some green light coming from this tube. You'd never know looking right at the tube that that's what's happening. But looking at it the right way through this compact disc will tell you that. Now, neon is one of a group of chemical elements called noble gases. And they're often used in these lamps. You all know about another noble gas, a relative of neon. It's called helium. Helium is used in helium balloons, but it's also used in lamps, such as this one. As you can see, it's a different color than neon. And if you look at the colors that it produces, you'll see, again, just a certain variety of colors, which you can't actually detect looking directly at the lamp. Now, I'm going to show you a couple more of these noble gases. Another one is argon. Argon is in the air you're breathing right now. About 1% of the air you're breathing is argon. And in a lamp, it produces this pretty violet color. But in addition to that blue, which you can see in the surface of the compact disc, you can also see other colors that the lamp is producing. It's not quite as intense as the other lamps, so you don't often see argon used in a sign. Now, there's one more of the noble gases I want to show you, and that one is krypton. Krypton comes from the Greek for hidden, because it is not very common in the air. It's only about 1 part per billion in the air. But it produces this rather bluish-white color when you look directly at it. And if you look at it in the surface of the compact disc, you'll see, again, a variety of colors that you cannot detect when you look right at it. Now, krypton happens to be element number 36 in the chemist's way of numbering elements. It has atomic number 36. This is the 36th anniversary of the Christmas show here. And so I thought in honor of this 36th anniversary, I would have a big krypton lamp made. So if Megan could bring that out for me. Thank you, Megan. It is a big lamp. I'm sure it's the biggest krypton lamp in the world.
I don't see any krypton, though.
Well, krypton is invisible gas, like most of the gases in the air. But if we want to see something happening, let's give it some high voltage. There's one for you to clip on that end, and one for me to clip on the other end. And you got yours on?
Yes.
Not touching any metal?
Not touching any metal, no.
Okay, just the glass. Okay, could we have the lights out? And when the lights are out, I will turn on the high voltage, and we have a krypton lamp for the 36th anniversary.
Oh, that's very pretty. Thank you very much. Thank you. Thank you. Thank you very much. Light?
Could you have the lights up, please? Thank you.
Disconnect?
Disconnect.
Yes. Thank you very much, Rod. I really appreciate this. Very, very special. Thank you.
Thank you.
Now I'd like you to focus your attention on the experiment I'm going to do right here in the middle of the lecture table, where I'm going to strike a match and light a burner. Can you see the flame? Can you see what color is the flame that you see now? How about right now? How about right now? How about this one? How about this one? Actually, these are all metal salts, and they're dissolved in a little bit of alcohol, and they're sprayed. And this one is lithium, this one is copper, this one is table salt, sodium chloride, this one is iron chloride. And what we're going to do is look at those with the lights down. So please turn the lights down. There is a very pretty color right there. Here's another one. Shall we mix them together like this? Yeah. How about trying this one here? This is sodium chloride, and this is iron chloride. Oh, you can see that too. Isn't that exciting? Yes, yes. And we'll go back and do this one, and do this one. Oh, do them together, right? You like that? Hey. Thank you very much. For the lights back up, I now will turn off the gas. Thank you. Yeah, you like that, right? That's good. Very good. I want to thank you for coming to share with us this very special celebration of our 36th anniversary. Thank you all very much. No matter what you do, remember that science is fun. Thank you very much, everyone. Thanks. Thank you.